Alright, so the question is, you got your game up and running, you've got a client daemon, you've got a server daemon. At this point, the code doesn't matter whether you're on the client or the server daemon. The code is the same. The specific question is, what does it look like for the daemon handling the message queues? So recall, if you have, say you have all 5 players playing. Let me outline this. All 5 players playing, 2 on server, 3 on client. Then there will be server daemon manages 3 message queues. Client daemon manages 2 message queues.
But there's 5 message queues on both machines, correct?
There are 5 message queues on both machines, so I'm specifically referring to what the daemon manages. Meaning that there are 2 game processes, 2 players on server, 3 players on client. So each of the 2 players on the server owns, if you will, has created 2 read-only message queues, read-only to them. They've created 2 message queues and made it read-only for themselves. In addition, the server manages another 3 on that same server machine, because it is mimicking the 3 players who are on the client side. And then you have the exact converse, which is there are 3 players managing their own message queues on the client, and then the client daemon manages 2 itself, mimicking the 2 players who are on the server. So there's going to be some sort of, let me change this, let me move notes.txt, let's call this message queue handler daemon handler notes.cpp, so we get a little syntax highlighting. So we got some sort of function, we call this the daemon message queue reader. Takes an integer that we don't care about. This function is the daemon's handler for SIGUSER2. And the challenge is that the daemon has received this signal sent by the message queue machinery, indicating that one of its queues has a message. However, we don't know which of the queues has the message. For example, given the above, the server daemon must check 3 different queues looking for the one with the message. This message would have been sent by one, what am I looking at? Server daemon. One of the server's two players would, let me see, this message would have been sent by, from intended for one of the three players playing on the client. We're going to need some global variables. String message queue name, 5. We need yep. MQDT. MQDT. Message queue file descriptor, 5 of those. For int I equals 0, I is less than 5 plus I. First thing we have to know, there are, so for the example, now this code is generic and works on either the client or the server. But I'm running off the example that I put in the comments there. Okay. So for the sake of just getting our heads wrapped around it, even though this code is generic and works on both the client and server, let's think about it in terms of it running on the server with the example situation that I've put here. On the server, there are currently 5 message queues. The daemon is only responsible for 3 of them. The other 2 are the players on the server. So, how do I determine whether or not message queue sub I is a player or being managed by the daemon? How can you tell? How do you know?
The player bit is equal to the daemon bit.
There you go. So if map board pointer is that correct? Oops. Okay. Then we need to look at creates the message queue. What am I looking for? I'm looking for a void int. Where are all my handlers? Oh, global resources. Ah, look at that, a bunch of handlers. All right, so this is from project 3. Recall that this setup was done when the message queue was created. And the idea, let's pull ourselves away from this project and think about it in terms of the designers of the operating system. A message queue is a global resource to which, in principle, any process on the system that with the right credentials can access that message queue. So the idea is, since it's a global resource, we may have a whole bunch of processes or a whole bunch of threads running simultaneously, and we basically want any one of them to be able to grab the message when it comes off the queue. So maybe it right, the designers of the operating system don't know specific projects, but they're envisioning the idea that you have some project where some message comes on the queue, a process grabs it, and then it runs off and it's working on it. And while it's working on that message, there can be other processes on the system that then are queued up to get the next message. So this code that I have highlighted then is going to allow any single process to do this. And when a single process does this, then this is saying that when the kernel throws a message onto a queue, the kernel will then send SIGUSER2 to that process to let it know, hey, you just got a message. Once you do that, you are no longer registered to receive SIGUSER2 because, again, given that kind of idea that I gave you, a different process would then run these 4 lines and it would register for it. Okay? In our case, we want to have this process over and over again receive SIGUSER2. So the moment we get a message and we are signaled, we need to re-register. So that's why this is the first thing in that signal handler, is to re-register. So let me see. I will then say, how do I want to do this? So if I know this is the order, I'm actually going to delay that a little bit. I guess there isn't any harm. I'm thinking there are a couple ways to do it. I could re-register only if I know that I received the signal. And if I've got 3, if I'm in control of 3 of these, presumably only one of the, unless it's a broadcast, only one of the 3 would have received that message. So what I will do is, I think I'm going to be lazy about it. So I'm just going to grab these 4, and there's no harm. I'm being lazy in that I'm re-registering even if I'm not required to re-register. Oops. So I'm in insert mode. Let's dump those 4 lines there. All right. So I'm in charge of this message queue, 1 of 3 of the 5. So I re-register, maybe redundantly. And then, I guess I should have grabbed all this code. All right, so let me go ahead and grab. I'm doing Control B Z to zoom in on this pane, but what I keep doing is I keep going Control B, and then I don't pull up on the Control key fast enough, and then Control Z stops the process. Then I have to say foreground to get the process back in the foreground, and now I do my command, take my finger off the control and hit Z. Alright, so let's look at what we got here. We're going to loop 5 times. If it's one of the queues I'm in charge of, re-register for signals, perhaps redundantly. Go ahead and set a buffer to grab the message. Here's where I'm going to receive the message. I'm going to keep receiving them as long as they're sitting on the queue. I have to provide a actual message queue file descriptor. That's line 22. So this is MQFD sub I. Since on line 26 I have my loop. And then right here is where here daemon sends G, what is it?
GSOC message.
Like that. Sends GSOC message across socket.
It's yeah, GSOC message the number of active players. Or added with the player it's being sent to.
That's all part of the protocol, right?
Yeah.
We have some error checking here. I think that for the sake of expediency, I'm going to fail silently. It's my exiting the loop, right? If MQ, so I'm just going to strip that for now. Let the daemon fail silently rather than figuring out the cascade of events to recover from that. Am I missing anything? I think that's about it.
What is the purpose of that final MM set? Is that to refresh it when you loop through again?
Yeah, so that's covering the case if you're going to iterate more than once on the while loop. You're going to immediately do another MQ receive, and I have to think if that's going to cause harm. The MQ receive does not create a null terminated string. It reads in X bytes. So the way to ensure that I get a null terminated string is I make sure the entire string is nulls, so it'll fill in whatever bytes, and subsequent bytes will be null. So that'll give me my null terminated string. And I studiously note that on line 37 I create a buffer of 121 characters, and on line 41 the maximum number of characters that I'm going to read in are 120, so I'm guaranteed that if I fill up the entire buffer, that last byte is a null byte and I have my null terminated string. Any other questions?
How is the message queue file descriptor with all the actual file descriptors and then getting to this part of the code?
How are those 3 file descriptors being initialized, you mean?
Yeah.
All right. So going back to,
Well, I know when when the client daemon starts up, it fills everything in, and then it opens one up whenever it receives it.
yeah, that's exactly what it does. You're following, you have to look at, there are 2 things to look at SIG-HUP. Yeah, this little bit here covers the case where the last player has left the game.
So how would you structure that? Would you just put all this stuff in one file?
The code generally, or I don't know that I'd put it all in one file.
Like the daemon.
Well, what I did, I guess I would.
Make that like an extern.
Yeah, you see, that's what I did for looking at. So these are I guess these are just, if you're going to have pure global variables, yeah, I would basically create this header file and extern all those global variables and then define them in a CPP file. It'd be nice to just keep it in one place, totally separate, because it's so easy to get spaghetti code where you're, well, I don't need to say anymore. I'm sure that many of you have experienced just that. You just get lost in the details, and you know the big danger with the global variables is that somewhere you're redeclaring the variable, and the problem is if you redeclare the variable in the global space, then you get a compilation error, and that's wonderful. But most of the time you're in some sort of function and you redeclare the variable and you aren't thinking about it, right? You're just saying int global whatever. And if this is inside of a function somewhere, then there is no error at all because this simply covers up and hides the global variable. So you end up with this funky bug where you need to be accessing the global variable, but you're accidentally accessing this local uninitialized or poorly initialized variable. And oh man, those bugs are such a pain in the ass to find. I don't have any global variables here because I believe all the global variables I had, I made just static variables inside of classes. There you go. Trying to see where I did my signal handlers. Draw map handler, read message handler. Yeah, those are there. Anyway, what else? I'll go ahead and kill this recording then, and I'm happy to look at code if you want to show it to me.